So lunch break, first day back with y'all. What am I doing? This stuff. So this was still on the section about writing inverses. And the steps are up here. Swap x and y, solve for y, replace it with the inverse of f of x. And again, this is 64 is easy, 65 is hard. So it's x equals negative 1/64 of y cubed. Oh, sorry. Yeah, that's right. I'm going to multiply both sides by a negative 64 because of the cancellation that it would cause on the right. So negative 64x is y cubed. Then I'm going to raise both sides to the 1/3 power. Actually, you could do a little bit of simplification on this one. The 1/3 power of negative 64 is negative 4, so negative 4x to the 1/3 would be my inverse. Ta-da! 65, which oddly enough I think has the same answer as 63. It's just amazing that that happened. I'm not even sure why, but we'll see in a minute. I could be wrong. Go through the process. You do it the same way 63 was done. X is 3y plus 4 over 6y minus 5. And what we'll do is we'll 6y minus 5 both sides. We're going to clear the fraction. Cancellation. Invoke the good old distributive property. 6yx minus 5x is 3y plus 4. And I'm going to take everything with a y and put it on the left, and everything else on the right. So 6yx minus 3y is 5x plus 4, because this went over here and this went over there. And I notice that both terms on the left now have a y in place. So if I pull a y from 6yx, there's a 6x and then a minus 3. I guess they weren't the same answer. I thought for some reason they were. No, this is what, sorry, I got thrown off. The amazing thing about 63 is that it was its own inverse. That's the amazing thing about 63. It was its own inverse. Pretty interesting, actually. All right, anyways, divide by 6x minus 3. And say that that is equal to the inverse of f of x. And that should be most everything with the inverses. Not a whole lot left of this homework packet. Just 3 good pages. All right, graph the function by finding the center, drawing the line of symmetry, and creating a table with 2 extra points, then state the domain and the range. So this is the square root function, better known as the arm. Looks like that. We're using the form y is a times the square root of x minus h plus k. That's the form we're using. It's not a hard form. The center, that's what I call it. In this case, it's the starting point. I know that I'm going to be 1, 3. And it's the arm. It's going to grow forever right, but it's going to contain the point 1, 3. What's done is we've been moved 1 to the right, and we've been moved up 3. The arm function does not have a line of symmetry. It just doesn't. But I've moved the x-axis and y-axis. Then make a table, all right? 2 extra points. If you plug in a 2, you'd have 2 times the root of 2 minus 1 plus 3. This becomes the root of 1, which is 1. 2 times 1 is 2. Add 3, you're at 5. So I contain the point 2, 5. And the next thing that you could actually take the square root of would happen when you plugged in a 5. If you plug in a 5, this becomes root of 4, and the root of 4 is 2. 2 times 2 is 4, plus 3 is 7. There's your arm. All right, this is negative 3 times x plus 7 to the 1/3 power minus 6. The mother function is x to the 1/3 power, which This is the 1/3 power, right? Which looks like this. It's the snake. This is telling me to shift left 7 and then down 6. I'm actually going to use the concept of initial slope on this one too. I could use it on this one too. I don't know if you noticed here, but when I went 1 unit over, I rose 2. Isn't that what that A value is right there? I rose 2 and ran 1. I'm actually not going to make a table for this one. Anyways, I go left 7, 1, 2, 3, 4, 5, 6, 7, and down 6, 1, 2, 3, 4, 5, 6. There's my centering. Mom has been moved from here to here. And because there's a negative symbol out front, the negative mother function would start high and move low. So I'm actually going to rise 3 units, 1, 2, 3, and I'm going to run back 1. I'm going to do the same thing down here. I'm going to go right 3, 1, 2, 3, and down 1. And then I'm just going to redraw that. And I probably worked that pretty good. But anyways, there she is. All right, here we have the 1/2 power. Do remember that that x to the 1/2 power is the square root function. That's what it is. So this is actually a square root function. So I'll rewrite it there. I think it makes it easier to see when you just do a rewrite. This is my arm. It's going to look something like that. It's going to be left 1, down 4. Left 1, down 4. And I'm going to redraw the x and y axis right there. This is my initial point. If I plug in a 1, nothing's going to happen, actually. Sorry, this is -1. If I plug in a 0, 0 plus 1 is 1. The square root of 1 is 1. Take away 4, it's -3. And you can see that I rose the understood 1 and ran the understood 1. I just need one more point. The next number I can plug in is going to be a 3, because that's going to make this the root of 4. The root of 4 is 2. 2 minus 4 is -2. And there's my 3 points for my arm. I have to go back and do domain and range, don't I? It says domain and range. I need to read the instructions. Heck, I made this sheet. The domain is going to be from 1 to infinity. The range is going to be from 3 to infinity. Here, which is kind of nice, the domain and the range are both the same. Negative infinity to positive infinity, or sorry, negative infinity to positive infinity. Here's an arm. The arm's domain is from -1 to infinity. And the arm's range is from -4 to infinity. The last one I'm going to do during my lunch break is going to be 69. Seems like a good number to stop at. That's a square function. Oh, that's a parabola. For real, we're going to go right 3 and then up 4. Just do an opposite of that. We start right here. By the way, the initial slope is equal to 1, because there's an understood 1 there. So, there she is. I'm actually not going to make a table. There's no need to make a table. All right, domain and range. Domain of any parabola that you will ever graph in what we now call algebra 2 is negative infinity to positive infinity. The range on that thing is going to be from 4 to infinity. All right, so there's 4 problems. It's a start. It's less I got to do tomorrow. Hope you enjoyed.